What is the period of a pendulum that has a length of 175 centimeters here on Earth? So I'm going to go ahead and start out using this formula omega is equal to square root of g over L. And really all I have to do, given the information here, I mean the only information I have is 175 centimeters. So I'm just going to plug that in to this formula. I mean the other information I have is that it's here on Earth, which lets me know that g is equal to 9.81 meters per second squared. But L, again, is equal to the 175 centimeters. I'm going to put that in as 1.75 meters so that the units work out. And my calculator says for this that it is 2.3676. I'm taking a few more than maybe I need here in terms of how far I'm reporting the decimal before stopping it and rounding. What unit should that be in? Well, it looks like the meters cancel here. I'd still have a 1 over second squared, but then there's that square root. And so I'd actually have 1 over second, and that makes sense because an omega should be in inverse seconds. And since omega is equal to 2 pi f is the formula that relates this to frequency, that suggests that frequency would be equal to omega over 2 pi. So I'm going to take this number, 2.3676 inverse seconds, and divide by 2 pi. And my calculator will help me out with that. And as a result, I get 0.3768. And I actually had a less rounded version I put in for this, in case there's any discrepancy if you're following this calculation and using the numbers I have written here, but hopefully they line up. This one I'm going to state the unit as hertz because it is in a frequency, and that is what is customary to do for that. And then the period is equal to 1 over that frequency, so I'm just going to take 1 over this in my calculator, and the result that I get for that is rounded to 3 places, 2.65 seconds. Now, if you had wanted to, I've done all this work starting from here because that's what I like to do. But if you said, hey, I had this formula written down, period is equal to 2 pi times square root of L over G. Could I just plug into that? And the answer is yes, you can. You absolutely can go, and we can check right now. If you put in appropriate values, so I'd put in 1.75 meters for the length divided by 9.81 meters per second squared, and then calculate that. It should also turn out, and it looks like it does turn out to be 2.65 seconds, which we can check with the answer in the slide, and it looks like that number is correct.